Have you ever wondered about the energy we use every day? Well, my name is James, and today I'm on a journey to learn about energy and how it can be stored. Join me as I discover about how energy storage could solve one of the greatest challenges faced by renewable energy today. But first, let's find out the basics. Energy is all around us, and we use it in different ways. In our homes, we use energy whenever we watch TV, switch on a light, or go online. Washing our clothes or chilling our food also uses energy. All of these tasks require energy in the form of electricity. As well as electricity, we also use energy in the form of heat. We use heat energy to warm our homes, but also while cooking, showering, and doing the washing up. Finally, we use energy for transport. Energy is needed to fuel the various ways we move from A to B, including traveling by air, by water, and by land. Even you need energy in the form of food to power your body. So here's a question for you to answer in class. I'm currently making myself a cup of tea using my electric kettle, and there's probably quite a few other people across the UK doing exactly the same thing. That means that there's a lot of kettles all being turned on at once. So here's the question. At what time of day in the UK do you think the most electricity is being used? To find out more, I have a friend at Glasgow Science Centre who's going to tell me all about it. Hi there, Harriet. Lovely to meet you. So today I am on a journey to learn about energy, and I was wondering if you could tell me at what time of day in the UK do we use the most amount of energy?
So we can find out what time of day we use the most energy by looking at something called the national grid. So the national grid is a network of power lines that gets energy from where we generate it at power stations to where we use it in our homes, schools, businesses, etc. So the national grid actually measures energy usage by the second. If you take a look at this graph here, you can see that we're having a spike of energy in the morning where people are getting up, they're turning on their lights, they're starting their days. It starts to level off around the afternoon, and in the early evening around 6 o'clock we have another spike again, which is our highest energy use.
Amazing. So according to this chart, the UK uses the most amount of electricity at 6 o'clock. So why is that?
Well, at 6 o'clock, most people are coming home from work or university. They're starting to cook their dinner, turn on their heating and their lights, and plugging in devices like computers and televisions. All of this requires energy.
Amazing. So it must be quite a challenge then to get the power that we need from our power sources in order to provide electricity for that time.
It definitely is, but the national grid works around the clock to make sure that we all have energy when we need it.
So what are the different sources of energy that we use then?
In the UK, currently, our main sources of energy are fossil fuels. So I'm talking about things like oil, gas, and also coal. But we can also get energy from different sources. For example, wind energy, solar power, we have hydroelectric dams and wave power. Then we also have things like biomass and nuclear energy. We can even use the heat in our Earth to generate energy with geothermal energy.
I'm picturing that it's 6 o'clock in the UK, everybody's coming home wanting to turn on the kettle, make their dinner. We can just use any of these power sources at that time then.
So unfortunately, we can't just use any of them to do anything. So I'm going to actually split these into two groups. On this side, we have types of energy that we have a bit more control over. For example, at 6 o'clock and we need more electricity, we can just burn more gas. The drawback with this type of energy, however, especially oil, gas, and coal, is that they are finite sources of energy. We only have a limited supply of them on Earth, and once we use them up, they're gone. A lot of these also produce CO2, greenhouse gases, which is what's driving climate change.
So what about this group on the right then?
On this side, we have types of energy that are renewable. This means that they produce almost no greenhouse gases.
But some sources of renewable energy are intermittent.
For example, with our solar power, we can harness the energy of the sun during the daytime, but of course the sun sets every night, so we don't have 24 hours of energy available.
Okay, so it must be quite a challenge then balancing which of these renewable sources that we can use at what time of day. And maybe that's something you can think about in your class. How could we use wind power, for example, when it isn't windy? So what's the answer, Harriet?
Well, if we head upstairs to the gallery, I can show you. So the secret to using wind power when the wind's not blowing is actually pretty simple. We have to be able to store energy to meet the demand when it spikes at 6 o'clock.
Oh, okay, so it's a bit like batteries then.
Yeah, but on a massive scale. This model, for example, shows us how we can store energy using hydroelectricity. Here, help me out with this.
Okay.
So as we're pumping water from the lower reservoir to the upper reservoir right here, we are using energy from our bodies, but it could equally be moved with a type of renewable energy source.
Okay, so I can see we're getting up to that red line now. What happens?
So right now we have potential energy. When we release the water from the upper reservoir, it's going to travel down thanks to gravity, and it's going to end up turning this turbine right here, which is going to spin a generator, which will generate electricity. Why don't we give it a try?
All right, here we go. Hey.
So this is only a model. The real systems are much, much bigger. Water is pumped uphill at nighttime when the demand for electricity is low. The water is then released through a power station hidden inside the mountain to meet the spike in demand at 6 o'clock.
So what are other ways of storing energy?
If we head back downstairs, I can show you.
Now this is not an ordinary balloon.
Oh, okay, so I assume that isn't helium in there then.
No, it's actually full of hydrogen. Hydrogen and a little bit of air. It contains a lot of energy. In fact, hydrogen powers our sun, and it's the most abundant element in the universe. We're going to release the energy from this hydrogen balloon by using a combustion reaction, which means we're going to set it on fire. So you might want to go take a seat in the audience for this one, and make sure and cover your ears when it goes off. Did you notice the energy being released?
Absolutely, yeah. There was a tremendous amount of light energy coming off of it, a lot of heat I could feel, and that was a tremendous amount of energy all from the hydrogen just inside that balloon. So we can see that energy can be released using hydrogen, but how can we store that energy?
We can store energy by using a little help from water. Our chemical formula for water is H2O because it contains both hydrogen and oxygen. We can actually separate those into their component parts of hydrogen and oxygen through a process called electrolysis. We basically just feed an electrical current through the water. So say we have a day on our wind farm where it's very, very windy and we're producing a lot more electricity than we actually need for the day. We can use that leftover electricity to manufacture hydrogen through electrolysis. So we're storing the energy in that way.
So we've talked about how we can store electricity as well as fuel, but what about storing heat?
I know just the person you should talk to.
So hi there, great to meet you.
So my name's Dr. Don John McAllister, and I'm a researcher at the British Geological Survey.
So today, Harriet showed me how to store energy through pumped hydroelectricity as well as hydrogen gas. I was wondering if you could tell me of any ways of storing heat energy.
We can store the heat energy from the summer, so as the temperature warms up. You might not believe that happens in a day like this in Glasgow, but it does. And on those days, we can take that heat energy and we can put it into abandoned mines, such as the one near Rutherglen that we're working on, store it in there in the summer, and then in the winter when we need the heat to heat our homes and so on, we can extract it again and use it to heat these homes.
Amazing. So it's a little bit like my flask here, where you can take this hot, warm energy, store it inside, and it'll keep it there for long periods of time.
Yeah, so it's exactly like your flask, in that your flask is an insulating layer on the outside, and in the mines are these big open voids which are surrounded by masses of rock. and the rock have insulating properties, just like the inside of your flask. So we can store the heat in the summer, put it down into these mines using boreholes, inject it into the mines in the water, and then in the winter we just extract it again using pumps from the mines, bring it up to the surface and distribute it to houses through heating networks.
And so what does the future for this technology look like?
We have a research site just down the river from here at Rutherglen, at the Cunningar Loop, where we're trialling this technology. So we've drilled 12 of these boreholes, and it allows us to experiment with these kind of injection and abstraction of warm and hot water and see how that affects the mine systems. So early days, but that's still something I think that we're looking at and has a lot of potential going forward.
So today we have learnt about the Earth's energy resources and how different sources of energy can be stored. Now it's over to you in the classroom to investigate how geology can help balance the supply and demand of energy. Good luck.